I have this really great shirt from a conference I went to in Wisconsin. It has a cow, but my cow has a cheese head because they have a lot of cheese in Wisconsin. It is cow, and it's saying mew. It's like moo, but it's the Greek letter. Anyway, we're going to go on a little adventure today, and we're going to go to Wisconsin as well. But before Wisconsin, let's start with GeoGebra. So we're going to be using GeoGebra to find probabilities. There are some instructions on how to do this, but it's going to be very similar to what we did for binomial distributions on GeoGebra. Same web page, very similar steps. And we're going to start by finding the exact probabilities to these ones. We did some approximations with the empirical rule. Let's see how good our empirical rule actually is. So we're going to jump over to GeoGebra. Oh, here we are right here. Before we went down to binomial, but now we're not going to click anywhere because we want a normal distribution. See that there's a spot to put the mean and a spot to put the standard deviation. So let's go back to our Portland example. 40 inches of rain, 8 inches of rain. Hopefully this picture looks pretty similar. They're counting by fives. We counted by eights. But if you find 48, it should be around here. It should be about at that inflection point where the graph kind of changes directions. Changes the side of the curve. Anyway, so if we do this, we can now answer every question that we want. So let me zoom out a little bit so we can see everything. And then we go over here and say, letter A, what's the probability that we're between 32 and 48 inches? Let's write it like this. The probability that X, which is our annual rainfall, is between 32 and 48 inches. Well, then we'll go over to GeoGebra and say, okay, all right, if you haven't seen this before, this button shows less than, this button shows between, this button shows outside, and this button shows greater than. So we want between. And notice that it defaults, putting 32 here and 48 here. That's just lucky for us. And you can find out that our answer is 0.6827. How close was that to our approximation? What do we guess for this probability? We guess 68%. The answer is 68.27%. Hey, empirical rule doing pretty good. Basically the same number. A little different, but pretty close. Let's look at B. The probability of being more than 48. What does that look like? Well, we're not going to use the between button anymore. We're going to use the greater than button, or right-sided. We want to be more than 48. So for binomials, you could kind of just drag this to where you wanted. But here, since there's an infinite number of answers, it's not going to be very precise. So instead, go down here and just type in 48. And you should be able to visually see that when you type in 48, we do see everything to the right of 48. And we're going to get 15.87%. As always, I will accept decimals or percents. Both are good. How does 15.87% compare to our approximation? That's pretty close to 15.87%, wouldn't you say? Empirical rule, you are fantastic. Wonderful. Let's keep going with letter C. 24 inches or less. Probability that X is 24 inches or less looks like this. And so we're going to use the left-sided one. Type in 24. Should look similar to our picture, right? We wanted this blue area. Does that look pretty similar? The pictures, this blue shaded area and this blue shaded area, yeah, it looks pretty similar. We estimated 2.5%. Okay, this one's 2.28%, still pretty close. 2.28%. All right, great. And then the last one was just 54 inches or less. We'll do that very similarly. And get about 96%. 95.99. What was my approximation? 96.5. I was a little bit more off, but that makes sense because we didn't really notice that we were like between 1 standard deviation above and 2 standard deviations above. All right. There you go. That's how you use GeoGebra to find these probabilities. One more big reminder for you guys right here. The probability of an event for a continuous random variable is the same thing as the percent of the area under the curve. So over here, when I say the probability of blue is 2.5%, that means 2.5% of this whole area is blue. Okay. When red or when green is 32%, that means the probability of being in that region is 32%, but it also means that that green area is 32% of the total area under the curve. All right. That's related to the concept of integrals in calculus, which we are not going to talk about. But if you have heard of them, there it is. All right. Let's do some examples to finish off this video. If you want to be bold, I highly recommend that you try these on your own. Pause the video, go through them, see if you can get it. Otherwise, let's look at it together. In a medical study, the population of children in Wisconsin were found to have a serum cholesterol levels that were normally distributed with some mean of 1.75 milligrams per milliliter and a standard deviation of 0.3 milligrams per milliliter. So define and draw the normal model. Well, we need to define our variables first. Let X be the cholesterol levels of a random child. I promised we'd go to Wisconsin. Here we are. I think that's WI. Okay, we have been told in a cholesterol level, our units are going to be in milligrams per milliliters. We've been told that X is normally distributed with a mean of 1.75 and a standard deviation of 0.3. Now we can just draw a picture. So we know it's going to look something like this. All normal curves. All normal curves look something like this. We know the middle is the mean of 1.75. And then the inflection point in either direction is 1 standard deviation above or below the mean. So add 0.30 or subtract 0.30. And then we could go another one, 2.35, or another one, 2.65. And in the other direction as well. And you can see visually what we talk about with the empirical rule, right? Most of the data is going to be within 1 standard deviation of the mean. Almost all the data is within 2 standard deviations of the mean. If we're outside of this red area, we are an outlier. We are unusual. And then really almost all the data is between 3 standard deviations of the mean. Almost everything. Very rare to be outside of this. All right. So if we have a child with a cholesterol level of 2.11 milligrams per milliliter, how rare is that? And what percentage of children have cholesterol levels higher than this? Well, where's 2.11? Kind of like maybe around here. What percentage of children have it higher than this? This percent. Whatever percent this is, which at a glance, maybe that's 10%. I don't know. What percent do you think that red is of this whole area? That's going to be our answer. So the probability that a random child's cholesterol level will be higher than 2.11, let's find that with GeoGebra. Also, notice that GeoGebra doesn't have a difference between greater than and greater than or equal to. It always uses the equal to sign. And that's because the probability of a single thing for continuous random variable, and this is kind of weird, the probability of a single thing is 0. We can only look at intervals. Okay? So greater than 50 and greater than or equal to 50 are the same exact probability. So that's the longer answer. The short answer is you don't have to worry about greater than or equal to signs compared to greater than signs for continuous random variables. So we know the average is 1.75. We know the standard deviation is 0.3. Does this look like our picture? Hopefully it does. Let's flip back and forth. The middle's 1.75. Yep, middle's in the same place. 2.65 is really far out. Yeah, 2.65 is really far out. Far out, man. Okay. What's the probability we're at least 2.11? That's going to be this button to the right. And again, it should look like our picture. It looks a little different from our picture, maybe. But that's just because of how I drew it. This probably, oh, I guess 10%. I did pretty good, huh? I didn't actually know the answer. It's 11.51%. And that's one of the great things about visualizing these models, is because when you visualize these models, you have an idea of what your answer should be. If we type this in and we get an answer at 50%, we should go, no. I just threw my pen on the wall. We should say no, but maybe don't throw your pen into the wall, because this red area is clearly not 50% of the total area. Got it back. All right. So visualization and thinking about things in the context of the problem is always really nice. All right, one more. Find the percentage of children in Wisconsin who have cholesterol levels between 1.3 and 2.23. Between 1.3, 2.23 is going to be like this green area. How big of an answer should we expect? Maybe like 70%, right? This is most of the area. Excuse me. I just had a tamale burp. Anyway, we should expect most of this, maybe 60%, 70%. Let's find out. So between 1.3 and 2.23, we use the between button. 1.3, 2.23. Oh, wow, it's even more than I thought. 87.84. Definitely looks believable, though. 87.84. So we can say the probability that a children's cholesterol level in this state being between these two values is, about 87.84%. Pretty likely that you'd be between these two values. All right. That's how you can find probabilities of normal random variables. Got more cool stuff coming up, but you've done the worst of it. Now we just build upon this. Good luck. Have a good one.